All right, thank you, Jessica. All right, and happy to be here on the last day of the conference. I hope everyone's having a great time and ready to go on out today with a bang. So hopefully this will be a good session here to close us out. So I'm going to talk a bit about measuring SOC defensive readiness and kind of how an approach to prioritizing some of the capabilities and skills of a security operations center. This kind of plugs in nicely with, if you were at the keynote this morning with Kevin Mandiant talking about how there's a lot that you can do in security operations. And I really enjoyed hearing him talk about that in kind of the interview. And this is one of the ways that I've been working at RangeForce on how to prioritize some of these skills. Don't worry, this won't veer anything into a kind of a sales strategy, although I'll talk a little bit how it connects with what we're doing there. But I want to start off with just a quick vision statement to say, imagine knowing that your organization has the security controls and people with the right skills to handle tomorrow's threats. And the tomorrow's threats is a key thing there to say it's not just about today, it's about predicting with some degree of accuracy what could happen tomorrow. And we'll say there's a threat where a cyber actor tries to get in and stolen credentials are identified and quickly reset. So, good, we were able to mitigate it. The organization had targeted the right controls to implement. The staff had the skills ready for this type of threat. There was preparation, and great. And so is it possible to kind of predict this kind of threat for tomorrow? And I say, yes, and I want to kind of take you on a little journey to show you what that looks like. So and how do we do this when resources are limited? The most important one, of course, is time. We don't have time to do everything, and that's what we're going to talk about here. So just a quick overview of myself. So kind of came through Department of Defense experience, then worked at a private sector in the Security Operations Center, penetration tester. Now I'm actually doing education and product direction at RangeForce. We're a cyber skills development company. And I've done lots of the cyber skills certifications, hands-on stuff. These are great things. Highly recommend them if you're looking into them. It kind of gives me a lot of experience with both red, blue team domains, a lot of different things to really put together the framework here we're going to talk about. My personal mission is to share the best cyber knowledge with the widest group possible. So how do we really get the right knowledge to the right people? And that's what we're trying to do. And one of the things I have is kind of I'll say an unorthodox opinion. Not everyone needs to be a cyber expert or cyber ninja, if you've heard that term. I try to avoid it personally. And we can actually get the right skills to the right people and make a big impact in that case. And also throughout this, if you go to my LinkedIn, I think it just says computing enthusiast, because I just love computers, and that's kind of my background, how I got into this whole field. So let's start here with the MITRE ATT&CK framework. I think if I asked you to raise your hand, everyone would say you've seen this before. It's been a great ontology or great framework of the last, 5, 6, 7 years of defining what are possible threat actors do. This is a great way to break it down to say, all right, the threat actor is going to do things like this. We can catalog their actions. We can provide references for these. We can link it to detections. All of that is really good. And so if we're going to start with talking about like controls for the security operations, we need to start with what are the threats here. And so this is a great framework, but how do we figure out the right ones to look for, the right ones to build our controls around? There's clearly some kind of middle ground between, say, antivirus or old malware that antivirus can detect from, say, 10 years ago, and that's one threat. Another threat might be someone giving a black hat talk, like I went to one this year. The guy was describing spending thousands of hours to figure out this one exploit. Okay, well, clearly those are both possible, but they're also not really the best focus of time. In the one case, basic system hygiene will take it. In the other's case, not very many threat actors are willing to put that much effort. And so how do we kind of wrap that up into things like MITRE ATT&CK to say, what will someone do or not do? And so this is where we're going to start talking about how can we prioritize these. If you're a huge organization with a huge budget, you might be able to say, let's prioritize all of them and build a very holistic control. Very effective, but not everyone can do that. So another way to look at it would be prevalence of TTPs. This is from a Fortinet report from a few months ago, just kind of breaking down the way in their threats, what they observed. And you really see, despite there being that huge matrix we just showed in the previous slide, now there's really just a handful of things that the threat actors really focus on. You really see the system binary proxy execution, typically some kind of like a PowerShell type thing, is really used a lot. And other things are not used very much at all. So there's kind of this concept of prevalence. We could build detections around the prevalence to say what's being used, where, how do I make sure I get logging for these things, which is important, definitely. But it doesn't really help us necessarily for what's going to happen tomorrow. But the other nice thing here is the more prevalent a given technique is, the easier it is to be detected. So if someone's using a certain technique a lot, it's actually easier to build a control, or if you have a security vendor or are a security vendor, you can build that, kind of with very low effort. So another approach for kind of prioritizing the attack techniques is what I'd call breadth of coverage. A couple of years ago in my corporate job, I was tasked to align defenses to MITRE ATT&CK, and I kind of took the approach of saying, all right, let's make sure we have at least X amount of techniques covered in each category or each tactic. So I just kind of highlighted that approach here where you see the red boxes, which mostly line up, just showing, hey, these are some of the techniques that we do have controls for, and we can kind of make sure that kind of the breadth of coverage we are likely to cover a new threat when it comes out. And of course, you prioritize based on some of the prevalence to say, all right, some of these are more important than others just by likelihood or what we have in our environment. And so we can kind of build that strategy. And this was very effective. But what I want to revise it now, and this is kind of where we get into this talk about really measuring, is how do we focus on attack sophistication? Is there a way we can align the attack techniques to adversaries based on what their level of intent or their sophistication? And if we can, then we can build a measurement model to say, all right, your security operations center or your organization is ready to defend against threats of a given level. And that really gets down to that measurement piece, which is very exciting. So to do that, we'll start by breaking down a given attack technique. So what is MITRE ATT&CK? I have an example here of the web shell, which is a server software component. This is a description of the technique. It gives an example of a specific implementation. It's great documentation. If you're on the actual web page, there's lots of references, lots of footnotes. I love working with the framework. What it doesn't do, and doesn't attempt to do, is to say how difficult is it to use this technique of web shell. And so if we're going to make a decision of do we include this in our threat model or not, we have to make some kind of judgment call. And so this is where in the framework I'm presenting, I say an attack capability, which is where we take attack technique and we just add one new attribute to it to say, what is the weaponization of this? Is it something that is public? Is it something that's altered or bespoke? And we'll run through those here in a second. So if we say the capability level of public, if we'll stay on the web shells just to keep a constant example. Public web shells exist. There's something you can go find. GitHub has them if you have any Kali Linux distribution. There's a number of them present. They do require some knowledge of how active web content works in terms of putting it in the right place, making sure it's executable, making sure that the web server knows what to do with it. So you need to have some knowledge there, but relatively little knowledge. And so if I put an order of magnitude of hours, I would just say it takes 1 hour. We could argue about 1 or 2, that's fine. The point is it's less than 10. Because if we start talking about 10 hours, now we get to another thing where we say altered capability. So we're still talking about web shell, still that same attack technique, but now we're saying something where it's changed in some way. And this would take a little more effort because we're talking about altering, say, a public web shell to evade simple detection. if we go back to that simple web shell you download from GitHub, if you try to do that on, say, your Windows machine or a corporate laptop, it will immediately flag as known malware. You'll probably get deleted or quarantined. But if you do a fun little exercise of how much do I need to change on that file to make it so that the AV doesn't find it, the answer is you don't have to actually change that much. But it does require some more knowledge of how antivirus detection works, of how signature-based detection, of how other kind of heuristics work. Requires some programming knowledge. You need to understand the language and understand what what the web shell is trying to do and how you can alter that behavior. But you can effectively make a change. The sum total of that skill and that level of effort, I would just put at, say, again, 10 hours, kind of that, again, order of magnitude. And so the third one, bespoke, like I said, is what if I create a novel web shell? So now I'm not starting from something that's already in a public repository. I'm making something fundamentally new, most likely adapted to a specific target. So we'll deal with an example of this later, but if I know what my target environment looks like, I can create a web shell that matches that behavior, that matches that file structure. This is going to require targeting knowledge. This is going to require much more programming skill. This is going to require just generally higher capability, and so we can assign it a 100-hour level of effort. In general, for these capabilities, whenever I talk about having some kind of skill, again, that cyber ninja concept, the time you spent developing that skill counts towards the capability, because we want someone spending an expert working on something for an hour is worth more than, say, a novice working on it for even 5 or 10 hours. So to summarize here, we have the public or common techniques. This is taking that public capability, targeting it at something. We can alter it where we're making some small changes, but still fundamentally the same technique. And then bespoke, or something that's within that same category, but somehow different from what else has come before it. And you can imagine these have very different detectability and kind of mitigations, which is the next part of it. So who is doing these kind of things? Let's talk about levels of threats. Again, so the framework I'm talking about here is the Defense Readiness Index. This is just what we call it at RangeForce. And it's a simple 5-level breakdown to say, all right, how do we show the differences from we'll say level 1, the opportunistic threats, colloquially script kiddies kind of thing, up through level 2, 3, 4, and 5 to that strategic threat. Strategic threat would be your traditional APTs, although the quote goes, they're only as advanced as they need to be. They might operate at lower level when needed. But the point is, they have the capability to go at that high level. And so who is doing this? And remember, they want to get some kind of ROI. So the return of investment for the level 1 is very different from, say, if I'm putting a lot of effort with my established threat at level 4. And just like the attack capabilities, we can say, all right, at each level, I have an increasing order of magnitude amount of time that I'm willing to put into something, again, based on the ROI. Ransomware is a great case study for this, which we'll talk towards the end, but to say, the more my capabilities are, the more money I can expect to get from ransomware, therefore, again, I can put more effort into it. And so this is where we can say, increasing amounts of time for each level of threat, and then break down to say, all right, which attack techniques are thus in scope for that threat actor. And so this is one that I realized I didn't put a legend on this. Well, it's minimized in that screenshot. The red ones are public capabilities. So we did an exercise, going through things at RangeForce to say, if we go with the MITRE ATT&CK framework, and again, we have these techniques, but which ones would take a very small amount of time? So in this case, less than 1 hour to use as a public capability. And the ones highlighted in red are the ones that were identified or selected for kind of the first round of the effort. And those are things that if you're a level 1 threat actor, we would say you'd have the ability to use public capabilities of those techniques. And you'll notice that one of them, if it's small enough to read it, phishing, is in yellow. That's because it's capable of being altered. Phishing is one of those things that it doesn't take a whole lot of skill or knowledge to be able to kind of target that more specifically. Therefore, we would say you need, even at level 1 of the Defensive Readiness Index, you need to be ready for that. And where it starts getting interesting is then I can say go to the next level of index level 2 of we have more time available to us as an adversary. So I have a larger pool of attack capabilities to choose from. And so in here you see, again, there's now more red things available and many more yellow. So yellows are the ones that are altered. So this kind of is a way to illustrate there's an increasing pool of things. But if I'm only concerned about these like lower level threats, I can kind of focus on these techniques to then tailor my defenses, kind of prioritize. So as you can imagine, it keeps going up 3, 4, 5 to the point where 5 would be effectively the whole matrix because all techniques would be available. So to kind of pivot the talk now about the threat modeling piece, we want to start talking about defend. So how do I turn a list of attack techniques into something actionable for my organization, something to prioritize? This is the MITRE defend matrix. Raise your hand if you've seen this before or worked with it. It's relatively new. Okay, but maybe half the people in the room. So this is something, it's officially still in beta, so there's changes. But it's a great project, and it really, similar to how attack is trying to define all the adversary actions, this is trying to say, well, if I'm a blue team, what are my actions available to me? And so, again, here's a taxonomy of what that looks like, kind of broken down into hardening, detecting, isolating, deceive, and evict. So what can I do to either prevent a threat, respond to a threat, or stop a threat in action? And similar to attack capabilities, we define a defend capability to say, all right, there's different levels of each of those. If I'm talking about network analysis or network traffic analysis, there's different ways I can do that. And so again, here's a simple three-step extension of that. Try to keep it as keep the changes as small as possible. To say, all right, there's a vendor capability. So that's something managed by a security vendor. The security professional in this case would be someone, you're working at a company or organization. You just need to know about that capability. What does it do? What follow-up actions are required if you get an alert? Just basic things. Then you get into tailored capabilities where the security professional needs to understand the capability to make changes, like tuning for a specific environment. If you're thinking about like the concept of SIM or log aggregation, they would kind of fall under this where I can deploy a SIM into a network, but unless I spend some time at least configuring it, it's not really going to give me much value, so I'd need to tailor it. And then finally, optimize to say some kind of security process or function where the professional needs to be able to apply that technique, where kind of analogous to the bespoke concept for the attacker, I'm doing something new or otherwise really doing very effective defensive security. And so these three kind of, again, build us a capability and skill framework based on these defend techniques. And just to throw a note there, the bolded lines, if anyone's familiar with learning or education and Bloom's taxonomy, those are directly from that taxonomy to make sure that it's compatible with education. And so to kind of bring it all together now, we have defined sets of attack capabilities for different threat actor levels. We have attack and defend relations that are provided, again, by the MITRE frameworks themselves, based on some of the detectability. And that gives us a set of defend capabilities, again, for each of those 5 levels. And this is where we start to actually get to say, this is something we can prioritize defenses against and now measure defenses and skills against. And the other neat thing about this is it's a numeric model to say we can kind of apply some risk management to say, all right, if I'm concerned about a public capability, again, something that's readily available or the lowest level of skill, I would expect a vendor capability to defend against that at least 90% of the time. If you work for a security vendor, I'm not trying to insult anyone, it's just the kind of a risk management kind of a thing. To say that we would expect at least 90% of the time to be mitigated. If I spend some time tailoring that defense, again, for my environment, I would expect to find that 99% of the time. And if I'm building an optimized defense or an optimized process against it, I would expect to basically get it all of the time. And you can think that's more defensive activity. As you can kind of imagine, the rest of the chart gets built out here with, as we look at altered attacks, they're going to get around the vendor defenses probably most of the time. Kind of flip that around now to say, the vendor defense is only going to get us 90 or 10% of the time. But again, if I go back to tailored, it's better. And this is kind of illustrating if you've done like red team penetration testing activities, you really need to do some of that extra work to make sure you're getting around the default vendor defenses. And then finally, the bespoke things get around the vendor defenses most of the time. If you're in the realm of a lot of red teaming, this is where you would expect to be. You never want to just be, your entire operation was blown by, oops, I deployed a common technique on a box, antivirus found me, and the blue team reset all my passwords. But as you see, the blue team can kind of get back up to defenses to parity by creating an optimized capability to counteract that bespoke one. And so this is where, again, depending on the set of techniques that are coming in or capabilities that you expect for the adversary to use, the blue team can focus their efforts on where does it matter. It's great to have the optimized defense for everything, every public threat. But again, the reality is resources are limited, and it might be better to put that effort somewhere else where I can expect an adversary to use a bespoke technique. That's where I really want to focus that capability. And so this kind of really puts together that model to say, where should I put the different efforts here? And to kind of recap back and summarize some of the where we're at right now. Here's DRI's Defense Readiness Index, just kind of summarized here, to say, all right, at level 1, I would expect to see opportunistic threat actors, script kiddies. Again, less than 1 hour per target kind of thing, so very, very low amount of effort. They're going to be using publicly available malware, credentials, that kind of thing, low skill, and for the most part, I can use automated machine detection. Again, a lot of that vendor-based managed things, which they fill a purpose. They're very effective at these kind of things. As we start moving into prudent and emerging, you notice that there's more altered capabilities where we start seeing in 10 hours, more the attacker is going to be spending more time. They might start using things like Metasploit, Cobalt Strike, that require different types of defense capabilities in order to mitigate. And so that's where you need to start looking at like threat intelligence, behavioral. You need to understand your environment better in order to be able to correctly mitigate those. And as you get into DRI 4 and 5, again, now you start talking about established like nation states operating at different levels, your high-level e-crime. In this case, they're spending hundreds or thousands, in many cases, of hours of effort to go after something. In this case, you really need to have deep knowledge of your analysis or your environment. You need to have very optimized defenses with that high-level defensive skill. But here's the cool thing, not everyone needs to be at that level, and that's where we can kind of start to build a maturity model to say, hey, I'm not necessarily concerned about those DRI 5 actors. I really just want to focus on DRI 3. What do I need to be able to do? And that's kind of the core focus here of we can now measure both where you're at and provide kind of a guidance over where you should be. Here's kind of a summary of, if we run through the exercise, again, it's a lot of boring tables, spreadsheets, transformations, that kind of thing. You end up with, again, the defend capabilities. So there's vendor, basic skills, and applied skills. And you have a increasing escalation of what do you need to do at each level. So if I'm only concerned about those lowest level threats, really I can get away with something like 12 capabilities, which one tool may provide more than one of those. The capabilities here are talking about defend from the D3FEND techniques matrix. So a really basic hygiene will get me most of the way there. And then my number of basic skills and applied skills really increase as we get to higher levels, and I need to be concerned more with those more advanced threats. And if this kind of is, if anyone's familiar with like CMMC or some of the other maturity models, this is very compatible with those. It's just trying to break it down into a different, a little more granular, again, focused on the orders of magnitude for the attackers and how to make that the most relevant. So with all that in mind, just want to kind of walk through a couple of case studies to then kind of close us out for today. And the first one here is, so some of the threats that have been in the news in the past, year or year or two. So this is one from earlier this year in June. There was a Microsoft Exchange. This is the headline here on Ars Technica for anyone who reads that. Microsoft Exchange servers were hit by a stealthy new backdoor. Okay, that's the headline, and if you read through the article, they talk about been used for 15 months, Microsoft Exchange servers, and it poses as a legitimate module for the IIS server, a part of Exchange. And so this is a web shell, and what can we look at it here? So we can kind of break down what the threat actor did. Their initial access was exploiting a public-facing application. In this case, they were using the proxy shell, or proxy login, which, from last year. They altered it for their set of targets. They installed a persistence here, the server software component. In this case, it was bespoke. Remember, the article is talking about it was a stealthy backdoor that blended in with the target environments. Definitely fits the definition here of bespoke. And we're able to kind of run through some crude metrics here to say, all right, they spent 100 hours on the initial access, plus 100 hours developing that persistence capability. And then we'll say just 100 hours, another general thing. And the article mentions they did it against 24 targets. So you end up, and I'm just adding in 10 hours per target for like just general, like you had to do hands-on keyboard kind of things with it. So you end up with 23 hours per target. And so what are the D3FEND capabilities make sense or for that, and do they make sense? Like, does this model give us something useful? Like, let's look at that. And so here's the set of skills or capabilities for that Defense Readiness Index 3. So again, across the top we have vendor tailored and optimized capability, and down the left these are the MITRE DEFEND categories for each one. And so these are, if we run through the exercise of it to say, these are the, in kind of more typical terms, what capabilities would you need to have if your goal was DRI3? You would need to have these kind of things like endpoint AV. You would need to have some EDR rules looking for process analysis. You'd want to have OS auditing, central logging of user authentication, kind of default OS alerts. And so this is where we can say, all right, would these have found this kind of attack? And the answer is, it's on the edge, like most likely yes, especially OS auditing, looking for new files. Since it was over 10 hours, you could start to say you might want to add some of the next level categories, which would be more like baselining web traffic inspection. And yes, I would say it would have a high likelihood of detecting the threat at some point, which of course speaks to the, I don't know for sure what level all of the targeted organizations were at, but you can kind of think about your own organization and would you be able to find something like that? So we'll do another case study here, again, kind of looking at that hours of effort. So WannaCry, this was a very, very big one a couple of years ago. And so we start off by saying what, the original technique behind it was the Eternal Blue exploit that was publicly made or available in early, was it 2017? So that was a reliable zero-day exploit against a common service. So the SMBv1 was enabled by default in corporate environments pretty much universally. It was available against a wide variety of Windows targets. The exploit itself was very reliable. I did some testing with it in pen testing labs, and wow, it works pretty much every time you use it. And obviously someone had built it before that. You can read some of the analysis blog posts, and it's fascinating to see the level of software engineering that was put into the exploit itself. And so that's clearly DRI5 level. So some organization, not trying to do anything here with attribution, but some organization put a lot of effort into that before 2017. And so, that was very high value. But then what happened? It became public. And so it got to the point where I would say it's DRI1. It became a worming malware. Someone weaponized it to put it into that point where it could just jump from system to system. And where once before you might have only had to worry about that if you were concerned about the DRI5 adversary, suddenly everyone needed to be worried about this because there were public techniques out there. The good news is when that happened, the patch was available, and a lot of the network traffic itself was signatured, and depending on IPS architecture, you could block a lot of that. So the capability to defend against it became much simpler after that point. It was still a huge deal. Personally, I was in vulnerability management at a large Fortune 500 company at the time, and we did a huge concerted effort. Fortunately, we were able to get ahead of it. And then we can also talk about an altered version. So it, of course, was not just WannaCry. There were other versions. We talk about not Petya, that we'd say they took maybe 10 hours to do some alteration of it and additional targeting to kind of put it more in that middle ground where it wasn't just every person needed to worry about this. It wasn't everywhere out in the wild, but it did have impact in a lot of places. So it required a higher level of defenses. Let's see, this is just another a little interesting case study that came up a couple weeks ago when I was, I'm not looking for things like this when I read threat studies or news articles. So there was a new method of running PsExec APIs. So it still falls under the existing MITRE ATT&CK technique, but they found a new way to run it where, again, it didn't necessarily use the existing ways. And this probably took 100 hours of effort. If you think about how did it, they had to learn about OS internals, about how Python called it, and to make it a useful tool there. And that took some effort, which probably would put it up into, that DRI, we'll say 4 or higher for the first targets. But then what happens is it becomes more broadly known. And so endpoint security, those vendor capabilities can update their threat feed. They can update their detection capabilities. And so it becomes more, in many ways, more easy to defend against. And so this is where, as a threat actor, or if you're thinking like a red teamer, I might have some custom tools that I've altered or bespokely created that I don't want to get widely out because I want to use them for myself. You want to make sure they retain value on future engagements, and threat actors have kind of similar capability. This is part of the idea of this entire framework is to say the threat actor wants to get ROI. They're not going to just throw everything all the time. And then one final case study, just because everyone is talking about ransomware, is to look at 2021 ransomware roundup. So the average demand was about $200,000 last year. And I went through some different statistics here from different companies. I found that said 32% paid the ransom, so of ones that made it that far. And so that would say the expected value, again, we're going to think economics here for a second, is, okay, if I'm the threat actor, $60,000 per attack, but that's only for attacks that made it that far. So, many of them would have been thwarted before that point due to one or more reasons. So, From some Microsoft sample data, they estimated about 2% of original attacks made it to the point of asking for a ransom. And so if you do some math there, you end up with about $1,000 per attempt. So if I'm a ransomware operator and I'm starting a new campaign or targeting a new company, I would expect to get around 1,000 from any one technique. Of course, not all of them will work. So this actually works out nicely, because if you think about, again, orders of magnitude, $100 an hour for a skilled cyber actor. If you want to go work in e-crime, I do not recommend it, but you could probably get that kind of money. Again, as a ransomware operator, I can now commit 10 hours of effort, or you would think of it in terms of money if you want, per attack, which puts it right in that DRI-3 category. So again, you start thinking about the common types of ransomware. This kind of e-crime actor would kind of fall in that DRI-3 category, which again includes all of your normal OS auditing, your defensive capabilities like I showed on the other slide. Just to kind of break down for anyone who want to see the spectrum of it, DRI-1 ransomware would be things like purely opportunistic, just, hey, I'm sending you random things, I might get money. But those are going to be the most common. They're going to be the ones that if you have any reasonable email security antivirus, you're going to block them. DRI-2, I would put things like ransomware as a service in here, where it's a pretty sophisticated. In fact, it's fascinating to read about some of the capabilities there, but they're ultimately used by a lot of people, and so the prevalence of them is pretty high. And then DRI-3, we just mentioned, is kind of the bulk of what I would say ransomware. But as you get into DRI-4 and 5, it's interesting because the amount of effort to execute the attack is probably not worth the expected ransom payout. So let's jump back to WannaCry, for example. Let's say you're the ransomware operator, you're in charge of your e-crime group, and you had someone spend 10,000 hours and developed a new Eternal Blue. So that cost your organization, probably $1 million or equivalent. Are you going to now go put that against an organization in the hopes of getting a $200,000 payout? Probably not. And so that's where, as you start looking at the capabilities that you see in the attack techniques for 4 and 5, you don't really see ransomware as much in that case. That's where you'd be, as an adversary, I need to go after something more valuable, whether that's a large financial breach, high-value intellectual property, information, influence, all those kind of things. So to kind of close us out here, some of the action things, like picking target DRI is, the whole idea here is how do I choose defenses that are high return on investment, and kind of deciding how much effort would an adversary use to target you. Some of this is depending on organization size, some might be the industry you're working in. And the key takeaway here is not everyone needs to be a DRI-5. That's part of the goal here, is to say, you can focus on some of the smaller sets if you're working for a not huge organization. This is just kind of a breakdown based on some of the data we have from our customers of kind of who's at different levels. And everyone we want to make sure has the DRI-1 knowledge, but fewer and fewer people as you go higher up. And so the kind of thing here, it would be choosing target DRI, measuring where you're at today. I'm working on a way to publish the skill set, to probably be as a MITRE ATT&CK navigator, to say, like the data you saw, of what's available at each level. And then that provides a roadmap to say, where am I at today through measurement, where do I need to be? And that's a lot of the work I'm doing at RangeForce, is to say, how do we, now that we've defined some of these skills at different levels, how do we help customers assess where they're at today, identify where they want to be and get there in the most simple manner. So that's kind of my personal goal. So that's kind of where we're at, and I appreciate you guys sticking around today. So I'm happy to take any questions. Jessica has a mic, or otherwise, thank you guys for coming today.